Hey everyone, in this video we're going to talk a little bit about compound growth, the compound growth formula, and how that kind of lead us into continuous growth and the continuous growth formula. So we've talked a little bit about compound growth before. We've definitely seen this formula where we say that A is the final amount, P is the principal or the starting amount, R is the rate, which you have to write in as a decimal. N is the number of times that your investment is compounded per year, and T is the time that has surpassed, usually in years. And compound growth means that the interest rate or the decay rate or whatever it is that you're measuring is being applied more than once in that particular year. So maybe it says that it's growing at 4% per year, but that 4% is or a portion of that 4% is applied quarterly or monthly or something like that. So the giveaway for us, the reason we know to use the compound growth formula is it usually says somewhere in the problem or in the description that we're using compound interest. For example, it may say that you're investing some amount of money into an account that is going to grow at 4% interest and it is compounded quarterly. Well, as soon as I see the words compounded quarterly, I know I have to use the compound growth formula. Or if I see it's compounded daily or compounded weekly or compounded monthly, those are all triggers for me to know that I'm using this compound growth formula. Okay. But one of the things that's interesting about the compound growth formula is that the more times I compound something in the same term, or in other words in the same year, the more my investment or the more whatever it is that I'm measuring actually grows. For example, if I have two separate accounts and one is compounded daily and the other is compounded monthly, well, even if they're going at the same rate, the one that's compounded daily will be worth more at the end of that year because that rate was applied more times. So the what can happen here with n is that as n gets larger, we're dividing this here by a larger number, but we're also raising it to a larger power. So as n gets larger, meaning we're compounding it more times, something very interesting happens to this function. So let's take a look. Let's imagine that we are going to invest $1 and we're going to invest it at 100% interest for 1 year. Okay? And we're going to let it compound an infinite number of times. In other words, n is just going to be infinity. Okay? So what the equation would look like, and although this is not the proper way to write it necessarily, but to give you an idea, it would look like $1 times 1 plus 1 over n, because 1 would be 100% as a decimal, okay, raised to the n times 1 power. Okay, but since we said that n is going to be raised an infinite number of times, I'm actually going to replace the n with infinity. So it's like 1 divided by infinity raised to the infinity times 1 power. Okay, so if I'm compounding it infinite number of times over that year at 100% interest, you might think that it's just going to grow infinitely large, but that doesn't actually happen. Okay, as we look at the graph, and if you want to plug this into a calculator, you certainly could. If you wanted to see what the graph looks like, it's going to start right here at 1. I'm just going to grab a different color here. It's going to start right here at 1, and over time it's going to grow and grow and grow, and actually it's going to grow very quickly at the beginning, and then it kind of levels out to look like that, and it has what's called a horizontal asymptote right around this value right here. And that value is a little bit below 3. Okay, it actually comes out to be about 2.718 and change, and it goes on forever. It's an irrational number. Let me just straighten that line out a little bit here so you guys have a better view here. So it kind of goes, like I said, it goes real quickly at first, and then it kind of steadies out and just gets real close to that asymptote and never quite touches it. And that number right there is actually a pretty special number. We have a special name for it. That is actually the number E. Okay, so that is the value of E right there. And E is found from this right here. So we don't really have to get into the whole definition of E or what E is, but E is basically what the value approaches as we compound it an infinite number of times. Okay, so that value E, we can actually use that for something that's compounded continuously. So in this next slide here, we can see that, all right, if we have continuously compounded growth, we have now a new formula. Okay, and this formula is A is equal to P times E, which remember is a number, to the RT. All right, way you can remember it is it spells PERT. But it's still, A is the final amount, P is the principal, or the starting amount, R is the rate, again, make sure it's a decimal, and T is the time in years. So for example, let's say we want to suppose we're investing $250 into an account that is compounded continuously for 10 years at 4% interest. Okay, and I want to know, well, how much is that investment worth when it matures? So again, I understand that I see the word compounded in here, but remember, it's compounded continuously. Okay, so if it's compounded continuously, that means that I'm using the PERT formula here. Okay, so what we're going to do is we're going to say that, all right, I know that this value here, the original investment, okay, this is going to be my value of P. Okay, 10 years, that's my value of T, and 4% interest, that's my rate right there. Again, I just have to make sure that I put it as a decimal, so my rate would equal 0.04. All right, so when I plug that all into my equation, we get A equals 250 times E to the 0.04 times 10, and we plug that into a calculator, and we get, it comes out to be about $372.96. Okay. If you're looking for the E button on the calculator, some of you may have trouble finding it. It is just to the left of the 4 key. That's if you want to raise E to an exponent. It says ln on the key, so you hit second ln for natural log. Or if you just want E and then you can type your own exponent in, it's second and then the divide key will help you find E. So there's actually 2 places you can grab it. Let's try out a couple of examples here. Okay, so let's say that we have a long-term CD that matured at a rate of 5%. Okay, so I know R, and was compounded monthly for 3 years. Now at the end of 3 years, it was worth $10,000. Well, I need to figure out how much was originally invested. Okay, so again, let's figure out what we know. I know my rate, so I know R is equal to 0.05. I know it was compounded monthly. Okay, so compounded monthly means that I'm using my compound interest formula. And that means that N is going to be 12, compounded monthly. Okay, for 3 years, so T was equal to 3. Okay, and at the end of 3 years, it was worth $10,000 right here. So that was going to be my A. So A is 10,000. So if we plug all of this into our equation, we get, remember the equation for compound interest is A equals P times 1 plus R over N raised to the NT power. So that's going to be 10,000 is equal to P times 1 plus 0.04, nope, sorry, 0.05 over 12 raised to the 12 times 3 power. Okay, and I have to solve for P. Now it looks like a challenging thing to do here. Okay, but if we look closely here, this part here, everything except for the P, that's all just a number. All right, it might be a gross, ugly decimal, but it's just a number. I can plug that into my calculator and figure out exactly what that is. So I'm going to take my calculator right now, and I'm going to type in parenthesis 1 plus 0.05 divided by 12, close parenthesis, raised to the parenthesis 12 times 3 power, close parenthesis, and when I put it in, I'm going to get 10,000 is equal to P times 1.1645, and it keeps going. All right. Well, now all I got to do is get P by itself, so I'm just going to divide both sides by this number, 1.1645, divide by 1.1645, and so if I do my 10,000 divided by 1.1645, I should get P is approximately $8,609.76. So that means that this here was the amount that was originally invested. That's the amount that was put into the CD, so that at the end of the 3 years, compounded monthly at 5%, we end up with $10,000. Okay? So let's try one more. Let's try one with continuously compounded interest. So here we have the same type of question, okay? A long-term CD matured at a rate of 5%, but this time it was compounded continuously for 3 years. At the end of the 3 years, we had $10,000. So again, compounded continuously means we're using the PERT formula. Okay, so we're going to say that A is equal to PE to the RT power. Well, I still know that R is 5%, 3 years. Okay, so T is equal to 3. Okay, and this right here, that's my A value. Okay, A is 10,000. So if we plug everything in, 10,000 is equal to P. Now remember, I don't have to find anything for E because E is just a number. It's a number like pi or any other number. Okay, E to the 0.05 times 3. Okay, and it's the same deal as before, where this highlighted region here, right, this highlighted section here, that's just a number. E to the 0.05 times 3. I can find that on my calculator, and it comes out to be about 1.618. Okay, so let's say that we have 10,000 is equal to P times 1.6183. Okay, so same thing. We're going to divide, and we're going to divide 1.6183, 1.6183. And so if we do 10,000 divided by that answer, we get P is equal to $8,607 and about 8 cents. Okay, so we can see we actually invested slightly less when it was compounded continuously. So there's not really a huge difference between being compounded continuously and compounded monthly. Mathematically speaking, there is, because they're different answers. But if you're looking at an investment, something being compounded continuously doesn't necessarily grow as quickly as you think it does. And again, it goes back to that point that even if it's compounded continuously, it still reaches that limit, that horizontal asymptote there at the value of E. Okay. So you're going to use these two formulas on your homework tonight, where you can complete it in class. You're going to continue the rest of the worksheet. You're going to do numbers 1 through 6. Okay. So I hope this video helps. Do the best you can with it. Try to write out what each value is, whether it's A or R or N or T, and try to really organize your work. All right. We will go over this in class on Monday. Okay. Hope this helps, and have a great weekend.